Model systems, coordinate graphing of systems of measurement. Systems of measurement. Two systems of measurement are going to be used. Each system of measurement signifies a model, a system, a model system. One system of measurement is going to use distance, and more specifically metric. The other one, angle and degree. These two systems I'm going to coordinate on a graph and join them, merge them together at an xy intersects 0. In mathematics, particularly graph theory and computer science, a directed acyclic graph, DAG, is a directed graph with no directed cycles. That is, it consists of vertices and edges, also called arcs, with each edge directed from one vertex to another, such that following those directions will never form a closed loop. A directed graph is a DAG if and only if it can be topologically ordered by arranging the vertices as a linear ordering that is consistent with all edge directions. On the right, you can see an example of a DAG, and the letters represent nodes, and these nodes form a line of causation. Again, on the left, you have a DAG. A causes AB, and BC causes D, and ABCD causes E. You can see 3 levels of causation, and on the right you have different examples of how that DAG can be labeled. A would be the origin, or 0, x and y intersect. B would be angle measurement. C could be distance measurement. And that leads to a hypotenuse at 7, 1, or hypotenuse in general. There are 3 lines of hypotenuse coming off this graph, 7, 0, 7, 14, 14, and 21, 21. E is probabilistic correlation, that the x-axis and the y-axis correlate with the hypotenuse, and the correlating number is 079, and that's consistent for these 3 hypotenuse, which we'll see coming up. This slide represents the Markov condition formula. As you can see at the top right, P and the values here, 707, 14, 14, and 21, 21, and PA 90, 180, 270. The value is I, P over PA, or PA into P is I, and that value is 0.07 8567420131839. This is values that are not rounded. If you go down here, you can see that the values are rounded: 7.1, 14.2, and 21.3, and the PA values 90, 180, and 270. These values produce an I value of 0789, or 079. The hypotenuse not rounded is here. The hypotenuse rounded is here. The values are consistent. 90, 180, 270 rather than 360. And you'll see what happens on the graph when I use 2.5 radius at 270 on the x-axis. So here is the graph. The value is 90, 180, and 270 rather than 360 here. And 270, that value basically is 0.079 when it's used with the hypotenuse and 270. And it actually creates a curve, and the distance is 21.3. Here you have the graph representing proportionality and between 90 and 5. The graph actually runs 1, 2, 3, but the radius is 5 count. So it's 5, 15, 5, 10, 15 on the y-axis here. And on the x-axis, it's 90, 180, 360, but is evenly spread by units of 5, which can also, which is seen here by 18, 5 creates 90. And you can see the proportionality in the graph. Here you have the graph again. You can see the division of the numbers 90 and 5 here, creating the hypotenuse 7, 1. This is 5 squared plus 5 squared equals c squared, which is 50, and the square root of 50 is 7.1, 7.07 rounded to 7.1. 180 divided by the hypotenuse 14.2 creates the relationship 0.079. And again, at 270, here you have the proportionality of 1, x and y at 1 and 1, and x and y at 0.1 and 0.1. And this goes down further to 0.01 and 0.01 xy. So this graph just represents proportionality. Here you have 0.1 to 0.9 and 1. And it continues to go down to 0.1, 0.01, 0.001 for the x and also the y-axis, meeting at the intersects x and y at 0.00. Here you can see the coordinate graph at 1 and 1 here, x and y is 1 and 1, 2 and 2 here. Again, this is downsized proportionally between the 5. If you have 5 here and 10 and 15 up here, and you have 90 and 180 and 360 here, this can also be graphed as 1, 2, and 3 proportionally, and creating the same hypotenuse here with a 90-degree angle. A squared plus b squared, 25 plus 25 equals 50, and the square root of 50 is 7.1 here. As you go down proportionally, you're getting these numbers starting with 3 and 2.5, and as you divide them by half, going down, they continue to create a constant or proportional number, 0.83333. And you continue to get that all the way down till you get into the decimal point, so 0.001, 0.00001, 0.00001. And if you put the x and y value at 0.00001 and the y value at 0.0001, regardless of the 0.0001 there, you're still getting 0 at the xy intersect. And you can see that to be the case here, 0.001 and 0.001 here, x and y. And here is proportionally down. So this is the itsy bitsy corner representing 1 with some quantum decimal dust, to the to the to the right. The end. Thank you for listening.